In this video, I'm going to remix a step file. I'm going to show you a trick for applying a chamfer or radius, even in a situation where it can't compute or you just don't like how it looks. It gives you a bit more control over the feature. I'll also show you one way to design engineered supports so that your model prints without auto-generated supports, and you can control better how it releases from your model and how it interacts with the build plate. And I will also show you a trick I use all the time in my prints when I'm dialing in a detail of that print to save time and just iterate faster. That may sound like a lot, because it is, and when I was cutting this video, I was really struggling to fit all of those different topics in and get it down to time. So what I decided to do was to leave all of those things in the video, but to include chapter markers at the bottom so that you can go in and jump to the area that you're most interested in. I don't want you to be stuck watching a video that just kind of feels like it drags on. So definitely use my favorite trick of watching the video in 2x. But also use the chapter list to jump to what you're most interested in and what you find most useful. If you do end up watching the entire video, fantastic. I really hope it helps you. So let's get into this. First step is to find a model to edit. In one of my videos, a commenter pointed out that it would be incredibly helpful to use a scraper and not touch the build plate because finger oils can impact your build plate adhesion. I will not use a metal scraper on my build plate. So I went and found this plastic scraper where the gentleman had created a whole bunch of different options. It comes in as a zip file, so you need to open the zip file and copy it to a local file before you can drag and drop it. The simplest way to figure out which file I wanted to edit was to take all of them and drag and drop them into Bamboo Studio, and then go over and select the Objects tab. After selecting the Objects tab, you can click on the part and it will highlight it and show you what the file name is. So I wanted to use V5, which is the longest handled. So I've edited step files before and I brought it in a different way. So I wanted to show another way of getting into a step file and editing it. So you go to File, Open from my computer, find the step file you want to work on, and click Open. And there's your file. Now, I generally like to move it toward the origin before I get started too much. So one way of sort of making this a little easier is you can create a mid-plane plane by clicking on both sides of your part if it's symmetrical, selecting your part and then moving it roughly to the origin. It doesn't have to be moved toward the origin. I just like working on things that way. So you can skip this step entirely or do it the way I did. After moving it to the origin, just eyeballing it, I went ahead and deleted that midplane. Then we want to go up and right-click here and enable Capture Design History. That allows you to see the timeline in the bottom bar. So we'll go ahead and save this file as well so that we can keep saving it as we go along. So now that we've done that, we have our step file. It has the design history, so every change, edit, or modification we'll be able to see show up in the timeline on the bottom of our bar here. The first thing I want to do is this particular file has a very gentle slope in the z-axis. Those don't print very well. The problem is that in the z-axis, slopes end up being stair steps. And so if your slope is too gentle, you see a very spread out stair step. There's not a way for it to do, unless you're using adjustable layer height, there's not a way for it to do it very smoothly. So the simple solution for this, and this is really, it's an aesthetic choice, is I'm flattening out that feature and then putting it in a 45-degree angle so that it will be a very clean step up and you won't have that stepped curve. So created the line, made sure that the line was locked to horizontal, created other features to lock to the line. Then going back into the sketch, I can set this at that 45-degree angle that I want. However, the problem with that is that 45-degree angle pulled my line up. So I have to add another line and then use X to make it construction geometry and then create the measurement that I want. After looking at it, I figured out that I want it to be around 13 millimeters, but the issue that I have is now my angle, my 45-degree angle isn't going all the way down. So I'm going to use a coincident constraint with another piece of construction geometry to create that. Now using the extrude, I switch it to join, and I also want to do it symmetrically. Now I can go back to extrude and use these features to cut and push it back up. And now I have a nice clean cut without having to create additional sketches. The next step, I'm looking at these radii. Looking at these radii, and they're a little tighter than I prefer. I like a little bit smoother path, which is an aesthetic choice. Also, it can affect your print times. Probably not much. So I create a sketch, I hit P to project them. I select those and hit X to create them as construction geometry. Now I can go back in and create 2 tangent circles for all the corners. This will enable me to create new radii in all of these boxes. So I create all the circles here, and then what I'll need to do is use the equals tool to constrain them all together so that every single one of those circles is the same size, and then I can just go in and use a dimension tool to pick whatever radius I want for all of them. So it's just a matter of going through and clicking 2 circles to set them equals to each other, selecting one group of circles and working through that. So then select a radius, try 4, looks a little smaller than what I want, so I'll go up to 6. Now, in order to fill in those corners, because the geometry that I've projected is construction geometry now, to fill in those corners, I can't select that corner with an extrude tool yet. I need to have a closed feature there so that it will be selected. So one way is to do the line, but the simplest thing to do is to use a 2-point rectangle and then apply tangent geometry to it. So we have 2 2-point rectangles. Make sure that they're outside the circle just so that the tangent geometry works. Select the tangent constraint, and then in the bottom right and top left circle, we're going to set it to tangent. Now you can see that that feature can be selected because it is now in a closed sketch. So we're going to do the same with the other one, and that will enable us to then use the extrude tool to fill in this handle and make those radiuses a little smoother. Selecting all of these corners, then I'm going to go through and select the to object and select the bottom of the object. Currently it's set to cut, so we switch it to join. It's joining to this body, so that'll all be one body when it's finished. I like to have a chamfer on the bottom edge of my build plate, so I'm using the chamfer tool as one way of doing this, and I'll show you another way to do this later on. Here's the problem with this way of doing this here, is because this step file has limited radius, it's not the complete smoothest curve, you have to go through and select each segment in that. There are some other ways to chain select those, but it takes a little bit more time. Whereas in these curves that I have created now in this step file, they'll be a lot smoother. So I just have to select one place and it will select the entire curve, and it's very easy to apply the chamfer to these features. Some of the chamfers and changes that I want to make have been completed. I want to add some more. Right angles are never great for printing and strength, so I just want to go in here to the head piece where the plastic blade fits in and strengthen these features by adding just a little bit more material around them and getting rid of sharp corners. Sharp corners are always bad for print speed and part strength. You want to avoid sharp corners as much as you can. You always want to smooth stuff out where you're able to. Okay? So, simple application of the chamfer tool, and that makes those features on the head a lot stronger. Now, here's the problem with the chamfer tool, however. If you have small features and you're trying to apply an angle that's greater than it will support, right? So I'm selecting all these small features here, and I need to apply a bit of a chamfer to it. It won't allow it because that small feature is too small and it can't compute the chamfer. All right, so this is where our new technique comes in. We're going to create the chamfer, but we're going to do it sort of manually. In order to do that, I've created a sketch. So I've gone into the sketch, selected the project tool using P, selected all the geometry that I want to include, and I've left holes in the geometry intentionally because I can smooth those out by applying a circle. So I'm going to drop in a couple of 2 tangent circles, and then using the coincident tool, make sure that the circles start where I think they should. Now, one thing to be aware of, though, is I use the equals tool here, and while theoretically these should be equal, because we're editing a step file, it does not work. It does not work. You have to delete the equals constraint here and treat these 2 circles separately, even though theoretically, if I were starting from scratch, you would be able to use the equals tool on those parts. So I had to delete the circle and go back in and fix those problems. And then after doing that, the tangent constraint was over constrained. That's why you see it in red. So I had to select it and delete it. And then I just created a little collinear line coming off of each of these parts, so that at the end of those things, the chamfer fades out, if you will. So I've created that sketch, and that sketch is my path, right? That's only half of the technique. Now I have to create another sketch. I'm creating it in plane. I turn off the visibility of that sketch so that you can't see the path sketch while I'm working on this. Using P, I project the parts into this plane, and then in this plane I'm going to form a tool. So I'm dropping lines and using X to create construction geometry. And now I'm using these lines to create a tool that will create my chamfer for me. So quick rough it in, and now I start dimensioning. So we'll set this to 45 and then pick a measurement here. I'm going for about a 1 millimeter chamfer. So set that to 90. And for certain dimensions, it's difficult to connect to them. So the simple solution is to create a line, make it construction geometry by clicking X. And then in some cases, you may need to use the coincident feature on that line. So pull my part up, grab that. It does not want to connect. Failed to connect. Wonderful. Over here, coincident, click. Won't do it. No, thank you. How frustrating is that? So I deleted the dimension first. Now I created the line, hit X to turn it back to construction geometry, clicked on it, and now set it to 1. All right, great. We've made progress. So now we need that line and that line. Click on it and make it horizontal. Okay, almost, but those need to be coincident. Finally it does what I want it to do. And that's the frustrating part. Sometimes constraints don't apply the way you would like them to. Try to figure out a different way to go about doing the same thing. So in order to create this chamfer, what we're doing is we're using the sweep tool. And so we're sweeping this path that I created previously in a previous sketch. When I try to select the last piece, it keeps wanting to select the whole curve, which creates a problem. So I ultimately grabbed the little ear and pulled it out, which is another way of achieving the same thing that I was trying to achieve in this particular part. Now, going back into the sweep tool, you can do much more complicated things than a simple chamfer. What I like to do is to have a chamfer on the bottom and top just so it's symmetrical. But when it's printing, You need the chamfer because you can't put a radius towards the build plate because the changing angle creates an overhang that's a problem where it's touching the build plate. However, on the other end of the angle, you can actually put in a radius and you won't have any issues with it. So right here, it has to be straight. It has to be a chamfer. But up here, you can blend into a radius. And so the beauty of this technique is it allows you to create a chamfer and a radius in the same feature. So I'm going to go back into my sweep and I'm going to change my profile to include that radius. And now I have the chamfer and the radius, and it smoothly blends across that feature. And then where the tool ends, it blends out into nothing. And it's very clean, really sharp, and a great technique. I encourage you to apply it in circumstances where it gives you the outcome that you want. So I throw a simple chamfer on the top feature. We're going to use the same trick once again. So first we create a sketch, we create our path, and then this time it's just a quick speed run. So I'm going to use the 2-point tangent circle, get it close to where I want it, just eyeballing it. It doesn't have to be perfect. 2-point tangent circle, looks right. 2-point tangent circle looks good. Grab the trim tool and trim off the edges, and now we have a path. So we finish that sketch. Here's our path. We're going to create another sketch. We're going to create it in plane. And we want to create, in this case, I'm doing a chamfer again. So we're going to control the depth of the chamfer and then the angle, set it to 45 degrees as before. And it won't sweep properly. You won't be able to select it here. You could use an inspect cutaway. But what I'm going to do, just to make it very simple to select, is add length to the feature and then turn that piece into construction geometry by clicking it and hitting X. Now when we go back into the sweep, it's selected things but it hasn't quite selected it correctly, so we want to hit the little X there and reselect our tool and then select our path, and there we have it. Quick chamfer even in tight radii where you can control it more. So we're just going to drop a quick chamfer on this little feature. This happy guy needs some little chamfered eyeballs. These chamfers will work easily. The radius isn't too tight, not a problem. So I went into Inspect, Section Analysis, placed the section analysis, and then adjusted the depth of the cut plane so that we got a clear cut and we could see all that we were doing in this area. Now it's a matter of, in the sketch that I created prior to implementing the cut plane, I use P to project the features into the plane that I'm working in, and now I'm placing the features that I want to grow. Exactly what this looks like, exactly the shape of it, doesn't really matter. I do place some dimensions here just so that I can control those things so they don't move around on me as I'm playing with these features. Since I'm using a 0.4 millimeter nozzle, I'm adjusting my feature size appropriately so that it'll be in the neighborhood of right at a nozzle width or less, so that the slicer doesn't place more than one width at the very top. I want it very narrow, and I just want a single extrusion to be connected to those other pieces. I've not just placed the very end, but I also have a support partway through, and then I'm adjusting the extrusion offset as needed so that I can get the width of it without any chance of it touching the walls. I don't want it to actually contact the wall of my feature. So I need to remove the cut plane to make sure that it's not in the way, and carefully examine it to make sure that I'm not touching the wall, which we're not. So that's very good. So this feature will print. It will only be contacting and touching our part in one tiny little area. So I drop it into Bamboo Studio and show how it looks. The issue is we have a back and forth. It's not a straight bridge from the piece out. There's a back and forth zigzag there. That won't be well supported by this geometry. So I've decided to add an additional feature that goes down the center of those pieces. So I have to create a sketch. One simple way of making sure that you have a centered sketch is to use a circle, right? Because the radius is always the same everywhere. So then I can tag off of the edges of the circle, and then using my circle again, I can find the midpoint of this feature and tie those pieces together with coincident mates, and turning the circles into construction geometry by using the X key. So now I have a feature that can be extruded. So I grab the extrusion tool and then extrude it. It's initially extruded as a cut. I want it to be a join, and I want the initial point to be an offset. Since the extrusion is in the negative dimension, I have to create the offset as a negative number and then drag it until it fills the space. So I'm looking to see if it's breaking through. It is a little bit. Not that it matters, but I push it over so that it's nice and clean. So there we go. We have a piece of geometry where the interface with the upper levels is very, very narrow. It's one width of extrusion. And this will support this, this double T shape will support the geometry that is created. So I make some adjustments to the infill. I flip over to cubic, which generally I prefer, up at 25%, and I'm looking through all the layers to see how it looks, where it's supported, and where features grow. I like the look of it. I want to do a quick print, but I'm going to use a trick here. I'm going to add a negative modifier, which is a cube, and then I'm going to change the size and shape of the cube so that it covers up my little part here. It's difficult to see. I like to do stuff in dark mode, but it's difficult to see exactly where it falls, so you have to change the angle so that you can get the cube in there. Now, one thing that I could do is add a second negative modifier, another cube, and try to slice off the piece so I'm just printing the particular piece that I want. I've placed them so they don't have overlap, so there's this little piece here that would be printed. But in looking at it, I realize, I could actually use the head of one of these scrapers. So I should move my negative modifiers so that it actually prints out the piece. And then when this prints out, if it's usable, I can actually use it versus just having to throw it away. So we move the modifier cube, and away we go to print the plate. Configure our settings and launch the print. Now, while that's beginning to launch, what I often do is I go back to my slice preview and I look through the layers again just to see if there's anything that I missed, because I can still cancel this print because it hasn't laid anything on the build platform yet. I can still cancel the print. But everything looks good here, and through the magic of editing, we jump ahead to when the print is finished. Under the microscope, you can see how the unsupported feature actually didn't do horrible. It's probably still usable. So if you wanted to print this with no supports, theoretically it's usable. It is kind of messy when you zoom in and look at it. On the right is the one that had the support feature of the T with the double cross on the top, and you can see where that got ripped out. Came out very, very cleanly. Looks really sharp, really clean, really good, very easy removal. We need to mirror the support features. So went in, grabbed that, mirrored that across the plane, drop that into Bamboo Studio, and once again you can see that the support features are in there, and if you look carefully, they're not touching the sides, so they should be easy to remove, and they're supporting both tabs. And now we print out that prototype. See how it turns out. Beautiful print. Flex the build plate. Barely have to touch it. These are the features. They printed really clean. They look really, really good. And they removed incredibly easily. So, if you would like to try this print yourself, check it out on MakerWorld. This is the part. Also, if you haven't played around with it on MakerWorld, of course you can look through the pictures. but they also have a 3D preview. Well, mine came in black. You can change the color to anything you want. Black is a little bit hard to see all the features, so I flipped to that. Also, you can see the different plates. So plate 1 was the one that I created that had the support features. Plate 2 does not have the support features. So you can do whatever you want. You can design your own support features and upload those as well. So check out the CAD files, and I hope it helps. If you have made it this far, you are a legend or very interested in this particular video. Please let me know in the comments what you think of this particular style of video where I go into more depth and show more of the steps and detail as I go through. I felt this video was getting a little bit long, but on the other hand, I have found a number of videos where it was incredibly useful for me to see all the details because I was not familiar with it. So I'm trying to find the right balance of presenting concepts and ideas that experienced designers may not have come across or may not have thought of. I hope it's a new idea or something new to you, but at the same time being able to introduce new designers in and give them enough information to know exactly what to do. The other thing that is commonly controversial is whether you put music behind your video. I figured I'd try it out. Let me know in the comments if you like it. Okay, maybe not that one. Let's see what else we have. This one reminds me of Mr. Rogers, like how people make stuff. This is the sort of instrumental background music that you would see. And for some reason I imagine a flower unfolding or something to this kind of instrumental music. Instead, we're unfolding an engineering design. But now we need like a finale. If you're still watching, I assume that you fell asleep and your device is actually watching you. If so, I hope that this is a playlist and you've selected autoplay and getting lots and lots of watch time on my videos. If not, thank you very much for your time, your attention, and please give me some feedback in the comments as to what you think would be best for a format moving forward. Oh no, we're low on battery. Oh man, this whole video, nothing just went quite the way I expected.